Untuk soalan ni, a horizontal platform in the shape of circular disc rotate freely in horizontal plane about a frictionless vertical axis. The platform has mass m100 kg and a radius r equals to 2 meter. A student whose mass is m60 kg, so there is a student standing on the platform walks slowly from the rim of the disc toward its center. So the student move from the rim of the disc towards the center. If the angular speed of the system is 2.0 radian per second when the student is at the rim, what is the angular speed when she reaches a point r equals to 0.50 meter from the center? So we need to find the angular velocity final when she reach the center. When she reach a point 0.50 meter from the center. So initially the distance is 2 meter. We need to use the conservation of angular momentum. Summation L initial equals to summation L final. And we know for this case, L equals to I initial, omega initial equals to I final, omega final. And it is given here that the moment of inertia of the platform is I equals to half mr square. That is for the platform. And there is a student here. We also have to consider the moment of inertia of the student. So the moment of inertia of the student, generally a point mass, we will consider that as a point mass. So the moment of inertia formula that we will use for a point mass will be I equals to mr square. Okay, so we're going to use moment of inertia of the student. Okay, will be I equals to the mass and the radius, which is the distance. This is the distance of the student from the axis of rotation, which is for this case. Okay, this one you need to consider this as distance from the center of rotation, from the axis of rotation, to the point mass. So for this, the initial distance. For initial, we need to consider both moment of inertia and also for final. So for initial, we have to consider I would be I student plus the I of the platform, omega initial, and then also I student plus I platform, omega final. So I student would be, we're going to use mr square initial plus half mr square of the platform times the omega initial, and this one would be mr square plus half mr square omega final. So we need to find the angular speed of the student when it reach a point r equals to 0.50 meter from the center. So in order to do this, okay, we just need to substitute all the value here, but please take note of the value so that you won't get it wrong. So for m is the mass of the student because we are calculating the moment of inertia of the student. So the student mass is 60 times the initial distance of the student. Initially, it's 2 meter from the center, which is from the axis of rotation. 62 square, half mr square would be 100 mass, and the radius of the platform is the radius of the platform is 2 meter square, and then times omega initial, which is 2 radian per second. And then we're just going to do this 60 times the final distance is 0.5 square plus a half times 100 times 2 square. So the moment of inertia of the platform, okay, stay the same, and then we want to find the omega final. As you can see here, you can find this, which is the distance is equals to, it doesn't mention the distance of the student initially, but it just stated that it walks from the rim of the disc. So we assume that the rim of the disc is almost towards the end of the platform. So that's why we just take the distance as the same as the radius of the platform. The distance is the same as the radius because the student stand on the rim initially, which is almost towards the end of the platform. So we will get the answer is equals to 4.09 ms negative, 4.09 radius per second.